Hey, welcome! Ever looked at your reflection and just thought, something's not quite right here? Well, today we're going to solve a couple of those everyday visual puzzles, the kind you see all the time but maybe never got the answer to.
First up, this classic. You know the one. You pick up a really shiny spoon, look into the part that holds your soup, and boom, you're upside down. What is the deal with that?
And then there's our second mystery. You put a perfectly straight pencil in a glass of water, and it instantly looks like it's snapped right at the surface. Now, these aren't magic tricks, I promise. It's just light, playing by its own set of rules.
So, we're not going to treat these like some complicated physics problem. Nope. Think of them as fascinating little deceptions. And by the end of this, you're going to be in on the secret.
And you know what? The answer to both the upside-down spoon and the bent pencil comes down to just two super simple things light does. It either bounces off stuff, that's what we call reflection, or it bends when it goes through stuff, and that's called refraction. That's it.
All right, let's start with that first one, bouncing, or reflection. This is the key to cracking the mystery of that spoon.
You see, whenever light bounces, it follows one simple, unbreakable rule. The angle it hits a surface with is the exact same angle it leaves at. It's totally predictable. And this is true for everything, whether it's a flat mirror or, you guessed it, a curved spoon.
And this is what makes a spoon so cool for figuring this out. It's not just one mirror, it's actually two different kinds of mirrors packed into one shiny object you eat cereal with.
So let's dive into that. We're going to break down these two types of mirrors that make up our spoon. One's called concave, and the other is convex.
So first, the inside of the spoon, that's our concave mirror. It curves inward, like a cave. Its job is to gather up light rays and bring them all together to a single point. But the back of the spoon, that's a convex mirror. It curves outward, and it does the exact opposite. It spreads all the light rays out. This difference is absolutely everything. Okay, so this is where the magic happens with the inside of the spoon. See how where you are makes all the difference? When you're far away, the mirror's curve actually flips the light rays before they get to your eyes. That creates what's called a real and inverted image, and that's you, upside down. But now look what happens when you bring it in really, really close. The image suddenly flips right side up. It becomes virtual and erect. Seriously, go grab a spoon right now and try it out. It's wild.
And this power to focus light isn't just for kitchen tricks, right? We use concave mirrors all the time. They're what make your car's headlights and flashlights shoot out a powerful focused beam. Your dentist uses one to get a big magnified view of your teeth, and some solar furnaces use massive ones to concentrate sunlight and create incredible heat.
Now, let's flip that spoon over to the back. That's our convex mirror. You'll notice it always shows you an image that's right side up, but a little smaller. But its real superpower, it gives you this huge field of view. And that's exactly why the passenger side mirror in your car is a convex one. It lets the driver see a much, much wider area. It's a lifesaver.
All right, mystery number one, solved. Now let's tackle that bent pencil. And to do that, we have to move on from light bouncing to light bending.
So this bending action has a specific name. It's called refraction. And it happens anytime light travels from one clear substance, like air, into a different one, like water.
But why does it bend? Well, it all boils down to speed. Light is the fastest thing there is in a vacuum. But as soon as it hits something denser, like air or water or glass, it actually slows down. And it's that sudden change in speed right at the boundary that causes the light to, well, take a sharp turn. And you can see exactly how it works right here. Imagine an invisible line drawn straight down at a 90-degree angle from the surface. We call that the normal. So when light enters the water, it slows down and bends toward that line. Then when it leaves the water and speeds back up in the air, it bends away from that line. It's that double bend that tricks your eyes into seeing a broken pencil. And this whole idea of refraction isn't just about cool party tricks. It's the absolute fundamental principle behind one of the most important inventions ever, the lens.
And it turns out lenses work a lot like our mirrors. They also come in two main flavors. A convex lens, the kind that's fat in the middle, like a magnifying glass. It converges light. It bends the rays inward. And a concave lens, which is thinner in the middle, diverges light by spreading it out. So same result as our mirrors, but this time we're achieving it by bending light, not bouncing it.
And that's it. There you have it. That upside-down face in your spoon and that bent pencil in the water, it all comes down to two simple but incredibly powerful ideas: reflection, and refraction. These are literally the building blocks of how we see and understand our world through optics.
So I'll just leave you with this one last thought. Every single time you put on your glasses, or take a picture with your phone, or look up at the stars through a telescope, you are using these exact same laws of light. Without this simple bouncing and bending, just think, would our modern world even look the same?